Welcome back to lesson 2 about the Python programming language. In the previous lesson, we learned that Python is good at doing math, right? We're going to use it for data science, so we better hope it's pretty good at math. And what we saw is that we could take values and combine them with what we call arithmetic operators, the plus sign, the subtraction sign, the division sign, multiplication sign, etc., and combine them to do math calculations in any cell of a Colab notebook like this. And as it gets executed, it gets printed out below. What we're going to introduce in this lesson is variables and data types. Now, variables in Python are very similar to variables in mathematics. It can be a letter or a word or a sequence of letters that we use to store a value in. So with this first expression you see x equals 23. What this equals sign is it's not checking for equality here. This is what's called the assignment operator. And it's taking the integer 23 and storing it under the variable name x. So if I come down here and print out the variable x, actually I need to run this cell first. Remember, the numbers in the top tell us which cells have been run. But now, if I haven't run this cell, then this variable x doesn't get saved to the memory of my notebook. So I need to make sure that this cell is run, or else when I come down here to this second cell, nothing will happen. So I'll say I'll print x here, and you'll see that that same value of 23 has been stored in my computer's memory, and it's been given this name x, right? I can do the same thing with the y variable. And you can see both of them, that those values have been stored under these names. Now, instead of using the raw values the whole time, I can now use their representations, these placeholders x and y, in just the same way I was using them in the previous lesson. But instead of using the raw numbers of 23 and 17, I'm going to use their variable representations and do x plus y, which is then again 23 plus 17, which should give us 40, right? An important thing to know about variables is that there's different kinds of variables. What we've used here, these are called integers. We're saving integer values to the variable x and to the variable y. So if I were to look at the type of my variable x using this built-in function called the type function, I go ahead and run that, it says int, right? X is an integer. The reason why this is important and that the type function is important is that specific kinds of variables have specific functionality tied to them. And these operators will work a little bit differently if I'm working with a different type of variable. Now, if I'm working with something numeric, like an integer, then this works just the same way as we showed in the last lecture. But we're going to make this a little bit more complex now. And as we're working with different types of variables, the behavior of some of these operators is going to change slightly. So as we're coding in Python, we always need to be conscious of the type of the variables that we're working with because our code might work a little bit differently if we're working with a variable that's just holding a different kind of data. So down here below, we have a new variable type. This piece of text here is what's called a string. Now, a string is just a string of characters, right? So it's all these characters grouped together, and the way that I contain them in a group is I wrap it in quotation marks, either single quotation marks or double quotation marks, all right? It doesn't matter if it's single quotes or double quotes as long as they match. I just have to use double quotes on both sides or single quotes on both sides. You'll notice that once I save these to the variables z and w, then this plus sign works a bit differently. Well, how would you add letters together? You can't add them like you would numbers. What this plus sign does when it's working with string variables is it does what's called concatenation. It just means it sticks these two strings together. So it starts with Dennis is, and then it puts running late again right at the end of it. You see that's why we have is and running stuck right up against each other. But it's also combined them into a single string, right? You notice that this whole thing now is wrapped in these single quotation marks. Now, if I want to make sure that this ran and read like plain English, I might go ahead and put an extra space in here. And then as it gets put together, it reads more like English. It doesn't stick those two words together. But this is the same arithmetic operator we saw before. It's the plus sign, but now in terms of using string values, this behavior changes a little bit. So if I print out type z, right, you can see we're working with strings here. I could do it with type w as well, right? By the way, I'm printing out type Z and type W, but I'm only getting one of them down here below. This is a feature of Google Colabs where they will only output here below the cell the very last thing to get returned in a cell or to be run in a cell. So if I want to output multiple things that I'm calling in a cell, I need to explicitly print out everything except for the last one. So if I do this, it will show me that both are type string. I'll just print both of them out so that they really match. All right, you can see both Z and W are indeed strings. The type function that we've been using here and here to tell us the kind of data that is stored to a specific variable is what's called a built-in function in Python. A function is, we have a variable name here, but then we get these parentheses on here, and these are tied to a specific piece of functionality. So when I put my variable inside of these parentheses, then the functionality takes place where it looks at what the data type is and prints that out, right? The print function is another kind of built-in function, and it does something very similar in that it prints out whatever gets passed into its parentheses. Don't be alarmed by these built-in functions. We'll start using them, and they'll become second nature to you in no time. But again, just to reiterate here, the most important thing to remember from what we've shown in these two cells is that Python code might change its operation, specifically these operators change how they work, based on the kind of data they're working with, based on the type of the variables that they're used in conjunction with. So we need to be conscious about variable types as we begin using variables more heavily and saving pieces of data to variables. So let's take a look at maybe a more real-world example, right? One of the reasons why we like to use variables is because when we're writing programs, there becomes a lot of values to remember, and we can't work with the raw values all the time. Sometimes it's helpful to store them in a variable and then manipulate those values and then restore them to a variable, right? So what we have here is we have our monthly income, our tax rate, and our expenses, right? This is a lot of information here. We have a total of 7 variables, but we see actually a new data type that we haven't worked with yet. Right here, this tax rate has a decimal portion to it. We see 0.184. That means that the tax rate variable here is not an integer. Remember, an integer is a whole number, negative, 0, or positive. So if I print out the type of my tax rate here, let me make sure I run this cell. All right, see the 13 in the top left corner. Now I know that it's been run. We'll see that it has the data type of a float. Float is short for floating point value. It just means that there's a decimal portion with this number. So both of these data types, both integers and floats, are numeric, but they're a little bit different in that integers have to be whole numbers, but floats can have a decimal or fractional part associated with them. So we're going to take a look at our expenses here, and we're going to see if our monthly income is enough given our tax rate to cover our expenses. And you'll see that as we write an equation that will allow us to calculate all of this, it will be much more readable code if we use the variable names instead of the raw values. So as we scroll down here, you'll see we have income after taxes. We want to calculate our after-tax income. In order to do that, we'll take our monthly income, which remember is 5,000, and 1 minus our tax rate, and then we'll multiply them together. So this will give us the amount of income we have remaining after we've paid taxes. All right, so I can run this cell. If I'm really curious what my after-tax income is, I can print it out. All right, and now here's my after-tax income. You'll notice that it's 0.00000005. You might say, why is that? We didn't assign anything with a funny decimal place like that. Well, this could be just due to the multiplication, but also sometimes Python, when it gets down to really small decimal levels, gets a little bit off in one of the last digits. Has some rounding errors that occur sometimes. So sometimes if you're expecting something like 4,080 and you see 4,080.000003 or 4 or 5 or some single digit here at the end, just know that that's a slight inaccuracy due to how this data is being held in memory. So don't let that alarm you. Next, we'll look at the total expenses. We'll add all of those up because we want our net income, net income after we've paid our taxes and after we've paid for all of our expenses. So what we'll do is we'll just add up all of our different individual expenses and then hold them in a single variable called expenses, right? So let me print out expenses too, just so we can kind of follow our work. We'll see what's left over. What's left over after we've paid our taxes and we've paid for our expenses. Well, $1,760, right? So not bad. If we saved that much money every month, we would have a pretty good savings going on, build up an emergency fund and be able to then later invest it, do other things with it. All right, so you can see here that we did the subtraction here, but now I didn't store it to a variable. Because I didn't store it to a variable, my Colab notebook automatically outputted what was here. Now if I saved this to something like what I'm about to do in the cell below, it wouldn't be outputted, right? Because nothing's now being returned in this cell. I can then just type out max savings again if I'm curious, and it will still be outputted. So that's just a little trick with Google Colab cells. I'm actually going to put this back the way it was before, because we're going to save it to this variable in the next cell below. All right, so we'll actually save our after-tax income minus our expenses, and we'll call this max savings, right? I want to build up 6 months of an emergency fund, so I want to be able to cover my expenses for 6 months. So I'm going to take my expenses, multiply that by 6, and divide it by my max savings, and this will tell me how many months I need to save for in order to have a kind of 6-month emergency fund built up. All right, so as we run this cell, we see it takes 7.909 months of saving in order to build up our 6-month emergency fund. All right, so pretty cool. This is us using variable names that hopefully you see these are named somewhat realistically and in a way that helps us understand what the variable itself represents fairly easily. And then we don't confuse ourselves with just lots of numbers here. We can think about what the quantities themselves represent and work with them at a little bit higher level of abstraction. So in the last lecture, we also used arithmetic operators to make calculations, like addition, subtraction, division, etc. Some of the more common arithmetic operators. But what I want to show you is that these arithmetic operators may not act the way you think they would when they're working with a specific data type. So, or with mixed data types, like we're going to see in this cell. So we have x equals 23 and Dennis is. Remember, this is our x and our y from above. I've just copied them down here so that we can look at them. Well, what happens when we try and add together an integer and a string? What happens as we run this cell? Well, as we run this cell, we get an error, a type error. Must be string, not int. Now, this is something about the Python programming language. We can't add together two values that are of a different data type. Now, I could add together an integer and a float because they're both numeric, but I can't add together a string value and an integer value. So what we're going to do is we're going to take this 23, this integer value, and we're going to do what's called casting it. We talked about this a little bit before as well. We're going to cast it to an integer. I'm going to turn this 23 from being a numeric representation into being a string or a text representation of the number 23. And I'm going to do that by using the str method. And I'm going to pass in my variable representing the integer 23. And that's going to turn this into a string, at which point I will then be able to concatenate them together. And we see Dennis is 23, all run together, right? Because remember, when we're using the addition sign for strings, it's called concatenation, and it just kind of sticks those two strings together, right? If I wanted to make sure that there was a space here, I would need to come back up and put a space in my z variable above, at which point it would reflect that after the concatenation. So at this point, I just want to review or overview some of the most common Python data types so that your brain, you're aware of these, and when you see them later on, they won't be completely new to you. We've already talked about strings and integers. We talked briefly about floats, right? A float is a number like our tax rate that has a decimal portion. I'll create another float here. I'll just call it my float, and I'll make it negative 0.00003, right? Definitely has a decimal portion. Print, let's just look at the type actually of my float. Also a float, right? Just wanted to have a float numeric value here right next to where we printed it out so it was easy for you to see what a float is. One thing we haven't talked about is something that's called a Boolean. B-O-O-L-E-A-N, right? A Boolean value is a value that is represented by true or false. So to A, I've saved the value true, and to the variable B, I've saved the value false. And as I look at the type of A and B, they are indeed a bool data type. Bool is short for Boolean, right? This will be very important later on as we're trying to control how our programs flow, and we want the programs to flow only if certain conditions are met. We want certain blocks of code to run only if certain conditions are evaluate to true. But if they evaluate to false, we don't want those blocks of code to run. We'll use something called if statements to control when those blocks run. But Booleans are very important and will be used heavily in our activities later. So finally, one more data type we'll talk about here is something called a dictionary. Now, the behaviors of dictionaries are a little bit more complex, and we won't use them quite as often as data scientists, but they're still very important. A dictionary represents a list of key value pairs, all right? A list of key value pairs. Now let me break that down a little bit. We will create a dictionary by wrapping some key value pairs in what are called curly braces here on the top and the bottom. And then the value on the left of the colon is the key, and the value on the right of the colon is the value, right? So the string on the left is the key, the string on the right is the value, right? And so this is a way I can store pairs of information in a way that is really easy to get back out. I can also, it doesn't have to necessarily be strings on the right-hand side. It can be any data type here on the right-hand side. But on the left-hand side, the key always has to be a string. The right-hand side can be anything. So down here we have an example where our keys are strings and our values are an integer, a float, and an integer. So I'm going to add another cell here, and I'm going to show you just very quickly how we can access a specific value in a dictionary. And the way that we access a specific value, remember the values are these things here on the right-hand side of the colons, is by its key, right? So if I run this cell, because I need to get these variables stored in the memory of my collab, and then I type numbers 1, it prints out 1. If I print out numbers 2, I get the 2.0, remember the float, and then 3, and so forth. So I can access specific values in the dictionary by its key. And it's very fast to look up values in dictionaries when I'm doing something like this. Let me just show you this again for the activities dictionary. And let's get the sunny activity, right? Go for a swim. When it's sunny, go for a swim, all right? These are dictionaries. We won't talk about them super in depth in the future, but they will come up a little bit, and they are very useful. So just be aware that if you see these curly braces and the colons, the key value pairs, you're dealing with a dictionary data type. Dict. Dict is the type, short for dictionary. Finally, I just want to leave you with a reminder that based on the data types, our arithmetic operators work a little bit differently. Remember, a plus sign does addition when working with numeric values. A plus sign does concatenation when working with string values. And something that's funny about our true and our false values is sometimes the value true is represented by a number 1, and the value false also is represented by a number 0. So if I add these two Boolean values together, I get 1 plus 0, which is 1, right? So a little bit weird. Things get a little bit funky when we start working with odd data types, and particularly mixed data types, and adding them together. Sometimes some funny behavior happens. Maybe you didn't think that the number 1 would come out of this expression. There's certainly some stranger things we could have done than this, but just remember that sometimes our operators work differently if we're using variables of different data types. So be a little bit conscious of the type of data that we're storing to our variables.